Hey, I'm going to introduce our first speaker, Christy Heaton. She's going to talk on Web Maps 2 ways with Streamlit and PyScript. Christy is a geospatial engineer. She is now president of Kugos and organizer of PyLadies Seattle. Let's give her a warm welcome. Thank you.
I'm tiny. Hi everyone, welcome to Web Maps 2 Ways with Streamlit and PyScript. My name is Christy Heaton. I use she, her pronouns. I'm a geospatial developer. I currently work in the automated driving industry. I like maps, I like Python, I like making maps with Python. I'm also a big community person. I'm involved in PyLadies Seattle and currently the president of Kugos, which is the Cascadia users of geospatial open source. And I'm involved in other groups as well. I also like hiking in my free time, so that's going to be the theme of the map we make in a bit. And you can follow me on Mastodon, LinkedIn. If you have your phone handy, this URL will take you to the content for this entire presentation, code samples, deployed apps, more information about me and things like that. It also takes you to the same URL that's at the lower left of each slide, so if you don't happen to catch it now, and you can maybe catch it along the way. I'll also show this at the very end as well. So maps. I've always liked maps. I remember poring over my parents' atlas as a kid, and now I make maps for work and for fun. You probably used a map recently to find Revolution Hall, maybe find restaurants nearby. But when you can make your own maps, that's really fun. You can answer your own spatial questions, and you can make really fun graphics, like this heart-shaped map of all the cities in the world with cat in the name. But we're here to talk about web maps, which are a special kind of map that you access in a browser. They typically have interactivity. You can zoom in and out, maybe have filters. You can hover over things and see tooltips, that kind of thing. So this is a map of the total eclipse that happened last year, a web map. So in this talk, I'm going to tell you 2 ways you can create and deploy web maps. Neither way involves a ton of code, and both allow you to deploy without having your own server set up. So the rest of this talk is going to go like this. I'm going to introduce Streamlit and PyScript. Then we will make a web map with Python. Then we'll use that web map in a Streamlit dashboard, and we'll use the web map in a PyScript dashboard. And then we'll discuss the pros and cons of each. Okay, so let's jump right in. What are Streamlit and PyScript? Let's start with Streamlit. Streamlit is a Python library that allows you to create web apps very quickly with no front-end code experience. Just like with any Python library, you'll have to install it into your local environment, pip install Streamlit. And then from there, you can create an app, a Python file that will hold your app, so your classic import statements. Streamlit is typically aliased as st. And then you can start using Streamlit methods right away to build your app. So st_title will put a title on the page, st_write will put some text on the page. You can create a data frame and use st_write to put your data frame on the page. And then st_scatterchart will put a scatter chart of your data frame on the page. To run your new Streamlit app in the terminal, you'd use Streamlit run and then the name of your Python file. And then it'll open up in a browser window for you, running locally, and you can see your title, your text, your data frame, and your scatter chart with just, 5 lines of code? So that is Streamlit. Now let's talk about PyScript. PyScript is an open source platform for Python in the browser, which is really incredible. You can now use Python in your browser. You don't have to have a local Python installation. The easiest way to use PyScript.com is to create an account on PyScript.com, where you can create any number of PyScript apps for free. So once you're in PyScript.com, to create a new project, you could click the New Project button. But let's take a look at a simple app that I've already prepared. So this is the PyScript.com kind of IDE in your browser. You'll notice you have a little file system here, your code window, preview pane, this button you'd click to open your app in a new window. So main.py has all the Python code you need for your app. So I've thrown in kind of some sample code here. We've got some PyScript display methods. So display will put whatever it is directly on the page, some text or an object, whatever it is. Print statements will appear in a black terminal-like interface. So I have some print statements there so you can see what those look like. And then I have a little function here that links to a button that when you click it, it will print hello PyCascades. Let's look at the rest of the files we have. So index.html will contain a bunch of boilerplate HTML. So I didn't write this myself. The only thing I added here was a button that says click me, and that ties to that little function I just showed you. But otherwise, this was already in here. All the things you need to tell the browser that you're going to be using PyScript are already set up for you in here. And then PyScript.toml is where you would store any configurations for your app. So if you had any dependencies outside of the standard Python library, you would put those here. My simple app doesn't have anything. Okay, so this little bit of code is our PyScript app, and then you can see here's what the app looks like. We have our displays kind of directly on the page. Our print statements show up in a black terminal-like interface. And our little button down at the bottom, click me. If we click it, it'll print hello PyCascades as many times as you want. Okay, so that is PyScript. So to review, Streamlit is a Python library for creating dashboards, super easy to add widgets. PyScript runs Python in the browser. You don't need a local Python setup. So both of them are ways that you can create and share web apps using Python. Neither of these are specific to mapping, but we can use a mapping library like GeoPandas is my favorite, along with Streamlit or PyScript to build and deploy web maps. So the map we're going to make, the web apps we're going to make are about hiking in Washington, and as I mentioned, that's one of my hobbies. So if you ever get a chance and are able to hike in the beautiful state of Washington, we have volcanoes, beaches, forests, mountain ranges. I highly recommend it. So let's make apps that help us find our next hike in Washington. So this is the map we're going to make using Python. So it's going to be an interactive map. You can zoom in and out of it. There's going to be a point on the map for every trailhead in Washington state. The dots will be a lighter color if they represent a shorter hike, and a darker color if they represent a longer hike. And if you hover over any of them, you'll see more information about them: the title, the mileage, the elevation gain, and the region. Okay, so let's see how we make this map. There's two things we need. One of them is data with trailhead location. So this comes in as latitude and longitude typically. You'll also see coordinate reference systems like latitude and longitude. You'll see ones that aren't as common sometimes as well, but out in the world, general purpose, you'll find latitude and longitude point type data. You could also use lines, polygons, but in our example, we're just dealing with point data. So the data we're going to be using for our app comes from the Washington Trails Association website, Go Outside map. And I'm not the curator of this data set, so I'm just using it as is. If there's points outside of Washington, I'm just using it as is. But it already has the geometry, the XY, the latitude, longitude embedded into it already, so it's good to go. Okay, the next thing we need is a Python library that deals with geospatial data and maps. And as I mentioned before, I really like GeoPandas. If you're familiar with pandas, tabular operations, GeoPandas can do everything that pandas can do, but it can also do spatial operations and make static and interactive maps. It's really great. So let's make our map with GeoPandas. So the first thing we'll do is import GeoPandas, typically aliased as GPD. And then we'll read in our file of hike data. This is in a JSON file. It's actually a GeoJSON file because it has a geometric component. JSON is a file format for data storage, a text format. We're reading in this file as a geodata frame, so I might call it the geodata frame going forward. And then just like with regular pandas, you can look at the first few rows of your data set. I'm just looking at title, mileage, gain, region, and geometry, so we can just take a quick look at it. And there you go. We've got nice looking titles, reasonable looking mileages, elevation gain, region here, and then our wonderful, very necessary for mapping geometry column ready to go. GeoPandas has a method called explore, which I love. It lets you create a web map, an interactive web map on a geodata frame with incredibly small amount of code. So let's try it. So we'll take our hikes geodata frame.explore, and instantly we have a web map. We can zoom in and out. We have a nice little blue dot for each of our trailheads. If we hover over any of these trailheads, we'll see all of the attributes available for that trailhead. But I want to customize this. I want it to look like the initial map I showed you for with different colors, things like that. So we can customize the explore method to make this map look how we want. So here's how we do that. Now I've added a bunch of customizations. So the first thing I'm customizing is the tiles. And tiles are the base map layer, the map that appears below my trailheads. You can see in the previous default map, it's more colorful, it's very nice. But I just wanted a more grayscale map so that my colors would really pop. Base maps are called tiles because they are made out of tiled images. Okay, so I'm customizing my base map, then I'm customizing my markers, so I'm making the dots a little bit bigger. I'm setting the column to mileage. This means that the colors of each dot are going to be based on the mileage column, darker if they're longer, and so on. CMap is the color scheme I want to use to show that coloring. And tooltip, I don't want to see all the information for each hike, right? That was really big and overwhelming. I just want to show the title, mileage, gain, and region. And then width and height are just the size of the map itself. So we're going to be using this exact same code in Streamlit and PyScript apps. So you'll see this again. Okay, so let's start by making a Streamlit app using the map. So you may have noticed there are a lot of hikes in Washington. There was like dots covering the entire state. So if you were interested in choosing a hike in Washington, you would probably want to add some filters to help you choose so you don't have hundreds and hundreds of options. So that's what we're going to do in our web apps. We're going to use that map. We're going to add filters and make it look nice and make it so we can share it with our friends. So this is our Streamlit app. You can see we have a sidebar with filters on the left and then our map right here. So let's see how we made this. Have a single Python file that contains our import statements using GeoPandas and Streamlit. I'm also using Streamlit Folium, which I'll talk about in a sec. We're reading in our data as a JSON file, doing a little bit of code cleanup, preparing for future work. And then we have st.title. We'll add our title to our page. Next, we'll add that sidebar with the filters. So st.sidebar. We'll put whatever object you want in a sidebar on the left, really handy. So I'm adding a subheader that says filters. I'm also adding my distance slider. I'm hard coding in the minimum, the minimum distance is the minimum available distance in the data set, but I'm hard coding maximum distance to 30 because I personally don't want to do a hike that's more than 30 miles, and I just hard coding that in. It's just personal preference. Same thing with elevation gain, hard coding in a value that suits me. And then we're deciding what all of our regions are in the data set and adding a drop-down menu that has all of those regions, set defaults to all. Next, we have some code that filters out our hikes based on what the user has selected in the filters. Now, Streamlit does have a map method, st.map, where you can put in your data frame or geodata frame, as well as the column that contains the latitude and the column that contains the longitude. This will make a really nice map with a red dot for each of your locations, but as far as I know, you can't customize this any further. So let's use our GeoPandas explore method with the customizations I set up before. So this is the exact same code, same explore method. And I'm using st-folium, which is a Python library that is outside of GeoPandas or Streamlit, but it allows you to put a Folium map on a Streamlit dashboard. Folium is a Python library that wraps around the JavaScript leaflet library. And GeoPandas uses those things, so this is good. This is a Folium map, essentially, and we can use stfolium to put it on the page. Okay, so that's it. Let's take a look at how we can use our Streamlit app. The nice little filters. You can expand and contract those if you want. Let's set the distance we want to do. Go hiking this weekend, 10 to 14. And set whatever elevation gain you're into. You can see the map automatically updates. We'll choose our region to be Mount Rainier. Now, instead of having hundreds and hundreds of options, we now have just a few hikes to choose from that perfectly suit our needs with just a little bit of code. Now, if you wanted to deploy the Streamlit app, you have a number of options, but the free one that I know about is Streamlit Community Cloud. So you would have to have your code in a GitHub repo. You'd have to have a requirements file with all of your requirements, and then you could deploy to the Streamlit Community Cloud by using the interface they provide. And then you could share your map with all your friends. So that was how you would make a map with Streamlit. Now let's make a similar map with PyScript. So the PyScript app is going to look pretty similar. We have our title, we have our filters, we have a separate filter for min and max, mileage and elevation gain. Our filters are at the top, but same region drop-down menu, same map. So let's see how we can make this. So here in the PyScript.com interface, in PyScript.toml, again, this is where we'll put configurations for our app. My app depends on GeoPandas primarily, and because I'm using the GeoPandas explore method, I also need to explicitly install Folium, Matplotlib, and MapClassify. If I don't, I'll get an error to that effect. In main.py, I have the bulk of my app, so a bunch of import statements. I'm loading in my data, my hike data, doing a little bit of data cleanup. Then I have a function that sets the default values to be values that I think are good defaults. So when the user initially loads the page, the max slider value will be set to 15 by default, that kind of thing. Also finding all the region options in our region dropdown and setting the default to be all regions. Next, we have our make map function, which will find all the values of the sliders. And then because we have separate sliders for min and max, there's a chance the user could select a min that's greater than the max, and we wouldn't want that. We'd have a little bit of error handling to handle that case. Next, we have our same filtering code as we had in the Streamlit app. Whatever the user has selected in the filters, we filter out our hike data set by those values. And then our same old GeoPandas explore method here, and we're using the PyScript display method to put that right on the page. I have a function called attach listeners, which attaches listeners to the sliders so that if the user changes the value of the slider at any point, the map automatically gets remade. And finally, we have an initialize method that calls all of those above methods, and then we run initialize. In index.html, along with all the boilerplate that was already in that file, I'm adding the HTML for my minimum and maximum sliders, adding my hike region dropdown, adding a spot for error handling in case the user selects a min that's greater than the max. I'm also adding some JavaScript in here because I want the user to know what the value that the sliders are all set to at. So there's a little number to the right of each slider that will stay updated depending on the value of that slider. Okay, so let's use the PyScript app. So when we load the page, the values are set to the defaults. So tend to increase the minimum mileage, increase the minimum elevation gain. Then we can choose Central Washington as our region this time, and now we've got just 4 hikes to choose from with this particular filter set. And you can see the map automatically updated. Okay. So if you wanted to deploy the PyScript app, you wouldn't have to do anything because creating an app on PyScript.com, there's instantly a public URL for it. So there's absolutely nothing you have to do to deploy your PyScript app. Just view your page, copy the link, share it with your family and friends. So we have just made 2 really great apps, one with Streamlit, one with PyScript. Let's look into kind of the pros and cons of each. So with the Streamlit app, it was really easy to create a very stylish dashboard with any number of Streamlit features. Like, you didn't have to try that hard to make it look good. Kind of, someone has already thought of all that. I mean, this library is specifically for making dashboards. So very easy to make a nice, stylish dashboard that looks great. Anything you want to add to the dashboard, you would just read the documentation. There's really good documentation. You need a slider, you need a button, you need a drop-down, whatever it is. Check the documentation, add the method, and it'll appear on the page. So super easy to get a nice-looking dashboard up and running. Some cons of Streamlit. Well, because those methods are so handy, you're also kind of limited by them because let's say you want your sidebar filter to be on the top or the right or the bottom. No, it's always on the left. So, just like, it's so handy to use the methods that exist, but if you wanted something outside of those methods, you would have to do some more coding of that yourself. And with Streamlit, you have to have your local Python environment. You have to install Streamlit into it. Probably something that many of us are familiar with. It's not that big of a deal, but something we didn't have to deal with in PyScript. If we have a deployed app and we wanted to update it, we would have to push our code to GitHub and then go through the deployment process again. Again, kind of a typical workflow, but something we didn't have to deal with the PyScript app. But in short, I'm a big fan of Streamlit. It's really good at doing its job, which is making web apps with Python with very little code. So the PyScript app, some of the pros of PyScript are, the main one is that you don't need a local Python installation to use it. You don't need a GitHub repository. You don't need an integrated development environment locally. All of that is in the browser for you. It's also deployed for you, so super easy to create an app, get it started. I mean, it's deployed automatically. So really great, really fun to work with. It's also very flexible. You don't have, the same built-in methods as Streamlit, so you have to maybe code more of it yourself. But given that, flexibility, you can do anything. It's like Python in the browser. Whatever you can do with Python, you can do with PyScript. Some cons I encountered with the PyScript app. This one is specifically for my use case because I have really heavy dependencies in my app. I'm using GeoPandas and some other heavy libraries. And when you use PyScript, you have to load Python in the browser, then you have to load all of your additional dependencies. So that's a lot of work for the browser. And if you didn't need all those libraries, your app would be very performant. And I know that Streamlit or PyScript is being actively developed. Every time I use it, it's faster, it's nicer. So when you use these heavy libraries, there'll be some slowness on initial load. And I couldn't write the whole thing in PyScript or in Python. I had to write some HTML. I wrote some JavaScript. Even some of my Python smelled like JavaScript because I added those listeners. I didn't have to do anything like that with Streamlit. It took care of all that for me. But that's not necessarily a con if you're used to that kind of thing. But we're at a Python conference, so. And in summary, I also really like PyScript. It's so fun to use. Very flexible, takes away that hardship of installing Python, which a lot of newcomers have a headache with. And I know from other PyCon and other Python talks that I've heard about PyScript can be used for interactive documentation, education, again, whatever you can do with Python, you can do with PyScript. So that was Web Maps 2 Ways. Again, here's the URL to access all the material for this talk and find out more about me. If you want to talk more about maps, come find me later on in the conference. Thank you very much.